Good morning and a very warm welcome to all the people attending this workshop today, organized by Intel in association with Analytics India magazine. And today we are going to understand and learn how to accelerate PyTorch applications using Intel oneAPI Toolkit. To give you guys a brief background, developers often struggle with high computational complexity, algorithmic challenge, and inference of large neural networks while accelerating deep learning applications. PyTorch facilitates building these deep learning projects by allowing the creation and training of deep neural networks and the ability to perform accelerated mathematical operations on dedicated hardware. However, deploying complex models with thousands of millions of parameters and large number of layers require heavy GPUs. And that's where Intel extension for PyTorch IPEX comes in handy. It's a part of Intel's oneAPI AI Analytics Toolkit and is designed to improve the PyTorch CPU experience while achieving good performance. So this workshop is going to give us a better hands-on understanding of how developers can accelerate PyTorch applications using oneAPI Toolkit. Before we delve into the session, I would request you to register yourself on Intel Dev Cloud. The link is shared with you over the chat box. Please also use the event code oneAPI 18 August. It's a one word. So please register yourself to get started with this workshop. We are also running lucky draw contests wherein 10 lucky registrants on Intel Dev Cloud will get a chance to win Amazon vouchers worth INR 1,000 each. So please hurry up and register yourself on Intel Dev Cloud with the event code. The workshop session will run from 9:30 a.m. to 12:30 p.m. and all the attendees can share their questions on Discord. The link will be shared on the chat window. And on that note, I will hand over the session to Kavita, the Developer Marketing Manager APJ at Intel. Over to you, Kavita.
Thank you, Sujiti, for that wonderful introduction. And hi, everyone. This is Kavita Arur. I welcome you all to the Intel oneAPI hands-on workshop, where we bring in the Accelerate PyTorch application using the oneAPI AI toolkits. I have some brief ground rules for today's event. Ellen, if you can go to the next slide, please. Yeah. We have the Intel Dev Cloud access, and if you have been participating in a workshop previously, you would know the Dev Cloud access is mandatory. Sign into Dev Cloud with oneAPI 18 August as the event code. We might have some internet connectivity issues or go to webinar tech glitch, right? So please bear with us and we will come back to you very soon. Like Sujiti explained, the Q&As are going to be hosted on Discord. So feel free to join us there, and we have some of our moderators who can help you with your relevant questions regarding the workshop today. We will have some poll questions and trivia to keep this workshop not just from a learning perspective, but also fun element is included there. So participate and look forward for some prizes to be won through the contest. Okay, the next slide. As you all know that one of the key elements for developers when you're working on your projects is to see how innovation you can bring it from the workshops we are organizing today, right? So we're trying to introduce the platform to you. Devmesh is a community portal for like-minded individuals like you and developers who can create and share the innovation story with Intel and the other network available there. So all you need to do is sign up to devmesh.intel.com, create a profile for you, and start sharing your stories, start sharing your projects, irrespective of the segment, right? Whether you're working on AI, IoT, HPC, or oneAPI for that matter, go ahead and share your projects there. Some of the key benefits for you for participating on the Devmesh is you can, be an Intel software innovator. You can also, create your own blog stories, which will get amplified and promoted on Intel.com and Intel Developer Zone as well. You can connect with, your peers and community members on the Devmesh community. You can share your projects or collaborate there. We have our AI Builder network there. We have most of our innovators and student ambassadors participating in this community portal. So sign up there. The other benefit you have by signing up there is you can be a speaker at events like this, right? You can participate and be a key speaker for summits and events and workshops coming up. So sign up and look forward for more information there, and reach out to me for any further information you might need on Devmesh. We are organizing a contest for Devmesh, and this is specific. Yes, please, the next slide. So we are organizing a contest just for you guys who are participating in the workshop today. All you need to do is sign up to devmesh.intel.com, submit your projects. If you have your current projects that you're using PyTorch for, right, it could be replaced with either Intel's extension of PyTorch or Intel distribution of OpenVINO, or any other relevant components or toolkits of oneAPI along with DPC++. After you replace the components, you can share the performances, compare the performances with your stock counterparts, and the same can be submitted for Intel's evaluation. The contest ends by 30th of this month, 30th of August, to send in your project. So you need to go ahead and submit those on devmesh@intel.com and send me the link to kavita.arur@intel.com. The prizes will be announced by Analytics India magazine on 30th, and the top few winners are eligible for some exciting Amazon cash vouchers. Next slide, please. We're also running a short contest today, and the AIM team will add in more details of this on the chat window, and you will also see most of the the contest details been put across on Discord. So look forward for it. What we're doing is, on the contest, we'll have the trainers take you through the modules being presented during the hands-on session. You have to submit the optimized PyTorch code for both training and inference, and you can share with me the screenshot before we close the day or by end of tomorrow, which is 19th of August. So send me the screenshots to my email ID, kavita.arur@intel.com. All you need to do is participate in the hands-on sessions, sign up to Intel Dev Cloud, be active on the Dev Cloud for this 3.5 hours of the workshop, and then stand a chance to win the Goki smartwatch, and that will be announced by Analytics India magazine again. With this, I would like to bring in the Dev Summit to you all. The Dev Summit is basically focused on oneAPI, data parallel C++, AI, ML, right, for accelerating computing across mixed architectures, whether it's CPU, GPU, or FPGA, or any other accelerators. So this summit is specially defined for HPC and AI developers. If you are working on a similar background, you can participate and register today. We will send across the register link on the Discord and the chat window shortly. What you would learn from this summit is basically it's all for the AI and the HPC developers here to connect and listen to some of our industry experts, academia, and Intel speakers come in and share their oneAPI case studies, right? So we have some excellent case studies on DPC++ and AI ML platforms. So come in and join and try to explore what the community is talking about from the innovation perspective. So the registrations are on today. Feel free to register and participate at this event, which is happening on 15th of September. With this, I would like to introduce the speakers for the day. We have Lakshmi Nassim, who is going to be our first speaker for the event. He's going to talk about the oneAPI portfolio of offerings, as well as the introduction to Dev Cloud. Lakshmi leads the consulting team for developer products and consulting division within Intel Software Group. And in his role, right, he's basically giving a lot of expertise to our key accounts from Intel hardware across IoT client or HPC segments. He has also been working with some of our key customers to address some of these major challenges and issues. He has been working with Intel for nearly about 16+ years now, and he has a bachelor's degree in computer science and has completed his senior leadership program from INSEAD. He loves to read, write, and teach in his spare time. So he's available on LinkedIn and Twitter, and feel free to connect and network with him. Our next presenter for the day is Aditya and Jingsan. So Jingsan is a senior technical consulting engineer working at Intel. He has been with Intel since about 5 years now and has a very rich experience in enabling the developer community and our key enterprise accounts, right? And has expertise over HPC, deep learning performance or deep learning frameworks and performance libraries for high performance libraries for MKL. His research includes machine learning, deep learning, and optimization, performance optimization, and data analysis. So look forward for him to get a hands-on, and theory session today for the event. Our next presenter for the day is Aditya. Aditya Surveyor is the AI technical consulting engineer at Intel, and he holds a bachelor's degree in engineering physics from IIT Delhi and master's degree in computer science with AI, specialization from IIT Mumbai. Apart from his work, he loves to watch, play, and play football and cricket. So he's our trainer today for the hands-on lab. and he will talk more on that front in some time now. We have two of our moderators present today. We have Mandar Gurav, who is going to be our moderator on Discord. He comes in with a very rich parallel programming background, and he's helping organizations to accelerate their applications on GPU and CPU. He's been working as a technical consulting engineer at Intel and is responsible for enabling the internal and external customers to extract the best performance on GPU. And we have Mary as well in the team, who's going to help us and support some of your questions on Discord. So look forward for these two key TCs who's going to help you on the Discord front. With this, I hand over the session to Lakshmi. Lakshmi, over to you. Thank you.
Thank you, Kavita. Can you all hear me okay? Can you see me okay?
Yeah, Lakshmi.
Yes. Awesome. Okay. Thank you so much, Kavita. Thank you for that wonderful intro about the workshop as well as the introduction to the speakers. I hope all of you, in whichever part of the globe you are, I know we have attendees from India and outside of India across APAC. Many thank you for joining this workshop and spending your time, valuable time in this workshop. So here is the rough agenda for the next 2 to 3 hours that we have today. So I will introduce you and expose you to oneAPI. I know some of you who have been part of our previous workshops probably might have already been introduced to oneAPI. So I will keep it a little brief so that for those who are new to oneAPI, they are not left out. So I will keep it really brief and make sure that you're able to grasp what oneAPI is. And also, I'm sure a lot of you would have access to DevCloud, but in case you didn't have access to DevCloud, probably I will just walk you through the instructions for DevCloud. And we will also have a handbook which will basically guide you in case you missed the DevCloud setup part of it, right? So we will post it on Discord. Also, we'll post it in the chat window to make sure that you have the required infrastructure, because this is very important, because this is where you're going to do all your labs, hands-on labs on, right? So that's why it's important. And then we will talk about, first we will give you a theoretical overview of the Intel hardware features for AI. This is important because a lot of times we miss the basic understanding of what really Intel has in the cards from an AI standpoint, right? So we will talk about the critical features that enable AI on Intel hardware, right? So after that, we will jump into PyTorch and how the Intel extensions for PyTorch really use the hardware features that we will speak in the previous session. After that, we will jump into the hands-on labs for both training and inference. We will have like almost close to 40-45 minutes for the lab, where we will walk you through the how to use the Intel extension for PyTorch for both training as well as inference. And then we will conclude with showing you a demo of using Intel's OpenVINO toolkit, which is primarily a toolkit for inference. Right? We will also show you how to use a PyTorch model using and do inference using Intel's OpenVINO toolkit. Right? So this would be the pretty much the summary or the agenda for today. With that, let me straight jump into the introduction to oneAPI. So it is very interesting that I am actually at my sister's place, and literally there are 8 people logged into the internet at this point in time, right? So I have 4 of our kids, each of them logging into their school networks for their online classes, and I'm logged into this meeting, and I have my brother-in-law who's also logged into a different, his own corporate network, and my sister is a teacher, so she is teaching the kids, right? At this point in time, this is one of those, critical workloads which has actually shifted in overnight, literally after the pandemic hit in, right? So this has been online learning and online meetings, etc., has been a critical workload that has over the last 1 to 1.5 years, it has just transformed, right? Meaning it was a bubble, right? And now it is more or less, it is going to be part of our life, right? And similar to that, when it comes to the pandemic and the drug discovery or the vaccine discovery, right? That's another set of workload which really requires so much of compute. And every corner of the world, scientists and researchers are really using all the compute available to make the drug and also the vaccines. Of course, they are available just because we had this excellent access to compute. We are lucky to have the vaccine, right? And I'm sure maybe in the next few months we also have the drug that can cure the coronavirus, right? So all of this, the backend is the compute. And today, compute cannot just be one device, right? It cannot be just CPUs or GPUs, or it is a mix of all these different hardware, right? Now, given that the hardware is going to be multifold in terms of CPUs, GPUs, not a single hardware is going to be good at everything, right? So that's why for some workloads, CPU may be good, some workloads, GPU may be good, some workloads, FPGA may be good. And also we have a lot of other accelerators that Intel has got, and also the industry is innovating. And now the biggest struggle is, okay, we have these excellent hardware that can do this excellent computing, right? But now the biggest challenge is there are all these developers who are really trying to figure out, hey, how do I program to all these different hardware, right? That is one of the, if some of you have been programming to FPGAs, you know how difficult it is to really program to an FPGA, right? So the whole idea of oneAPI is to create a common framework that can help you program to these all different hardware, right? So essentially, the interface, the developer interface to all these different hardware is going to be unified through oneAPI, right? So that is the whole idea of oneAPI. So in nutshell, how are we accomplishing this, right? So how are we accomplishing this is, we just like how you have traditional languages like C, C++ for CPUs, we have something called as DPC++ or data parallel C++, which essentially what it does is it is going to really be talking to all these different hardware in a unified fashion, right? So that is what this basically this framework allows us. So you see here that DPC++ is one of the backbones for oneAPI. So so you will see that now, of course, right? Data parallel C++. So it is available in different forms and shapes. One is data parallel C++ as a native programming language, but you do need associated libraries, associated debuggers, profilers to profile the code that is being written on all these different hardware, right? So with this, so what we need to really do is we need to have those bundled in a way that is more developer friendly. So that is where you could see that I have highlighted some of these in red. That's where, especially for AI, there are some critical components that are packaged in the Intel's base toolkit. So if you Google for Intel's oneAPI, this is probably the structure or the package that you will get on Google, right? Intel's oneAPI is available in these different forms, different toolkits. The base toolkit, HPC toolkit. For the base toolkit is common for all these different toolkits, and what happens is that it is the base for really doing this heterogeneous programming, right? When it comes to programming all these different devices, this forms the base, and then you have these domain-specific toolkits, which is AI, HPC, the DL framework, which is more for the framework developers like TensorFlow, PyTorch, etc. And AI analytics toolkit for people like you who are data scientists, who are AI developers, who can use the optimizations that are there in the base toolkit. I will talk about more in the next foil. And also, I did spend briefly when I spoke about the agenda. I also spoke about the OpenVINO toolkit, right? So that is another toolkit for AI inference, right? So what we will do is, as the day progresses, you will get exposure to these different toolkits, and also you will get hands-on for these different toolkits, right? So that is the whole idea. So now, if you look at what the Intel's base toolkit is all about, right? So again, I have probably highlighted the ones which are really essential for AI in red, right? You can see that these ones which are in red, clearly those are the ones which forms the base for accelerating our AI workloads. Intel distribution of Python, I'm sure all of you, Python is literally the language for AI developers, right? So we have our own distribution of Python, where what we have done is we have optimized all these different packages like NumPy, SciPy, scikit-learn, etc. And then we have packaged it into Intel's distribution for Python. And apart from these, we also have these libraries like math kernel libraries, the data analytics library, the collective communication library, and the deep neural network library. So these are different libraries that basically accelerate your AI workloads on Intel hardware, right? So that is one of the key messages that I want to leave you with. When you use these libraries, that's where the concept of oneAPI comes in, where you use these libraries. These libraries are already optimized for Intel's GPUs, FPGAs, and CPUs. So you use these libraries, you already get the best benefit. If you feel that, hey, no, I have to write the code natively, you have the choice of using data parallel C++. And to the right, you do see that we have these profiling tools, which basically give you insights into what's going on inside the hardware, right? So this is in nutshell the base toolkit, and we will be using these libraries and in the AI toolkits, and then we will get the best out of the Intel hardware. So now moving on to the AI analytics toolkit. I'm sure some of you here have already attended one of the previous workshops that we had conducted. So the previous workshop focused on the Intel's optimizations for TensorFlow, and also we had hands-on labs for the machine learning part using scikit-learn and also the data analytics library, right? So now what we want to focus in this particular session is about the Intel's extension for PyTorch. If you have a PyTorch framework, if you have a model that's developed on PyTorch, how can you accelerate, how can you make it run better on Intel hardware is what we will see and we will focus on in this workshop. In nutshell, AI Analytics Toolkit is all that AI developer needs. We have these different frameworks which are optimized for Intel hardware, which is the Intel's optimization for TensorFlow, PyTorch, and also we have already the standard models which are already optimized on Intel, right? That is part of the model zoo. And also we have a low precision optimization tool which converts your FP32 and to models to int8 and so on, so that you get better performance, maybe with a little bit of trade-off on the accuracy, right? So this is the deep learning part of it. On the machine learning, we have a lot of these libraries like packages like scikit-learn, XGBoost, optimized on Intel, and eventually some of these use the math kernel library that I just spoke about in the base toolkit, right? And the same with for data analytics, we have the Intel distribution for Modin, which basically helps you speed up the pre-processing for the data, which are again using the OmniSci backend. And also a lot of the core Python packages have been optimized to run best on Intel. Whether it's NumPy, SciPy, NumPy, Pandas, all of these have been optimized to run best on Intel. Okay, so with that, let's just have the first poll. Kavita and team, can we just have the first poll on the screen, please? How many of you have access to DevCloud? So is the poll up, Kavita?
Yes, Ellen, the poll is up. You can also see the responses in the control panel.
I can see the poll.
Sure. Okay. So I can see roughly around 60% have saying yes. Yeah. Can we just have everyone answer the poll? Do you have DevCloud access or not, please? Okay, we see a 60-40 mix now. Okay, so those who don't have access, please don't worry. We will walk you through the process in any way so that you don't have to really worry about, hey, no, I don't have access. What do I do, right? So we will walk you through the process so that you are registered and you have access to DevCloud and you can do your hands-on session, right? So don't worry.
I'm closing the poll.
Sure, no problem. Yeah. Okay, thank you. So for some of you who are not aware, so Intel's what is Intel Dev Cloud? It is just a sandbox for you to play and experiment with oneAPI and your own workloads, right? It will just help you try out your code on the servers that we have in the cloud environment. It is just a sandbox for you to really test and evaluate the performance using the oneAPI tools, right? So maybe Kavita, as I just flashed the file, if you can just put this link as well in the chat window, that would be great. So please make sure that you have this. You click on this link and then make sure that you put in the DevCloud access code. It is ONE small and API all caps 18 AUG caps. I repeat, ONE is all small, one API is caps, all API is caps, 18 August, AUG again caps. So if once you click on this link and use this, just keep this DevCloud access code handy because this will be needed as you try to register. And okay, so you should be in this, when you click on this link, you should have this enrollment form. You click on register. And you would get this form. You just have to enter your personal details, your name, email IDs, password. You give a password and then a country and a phone number is optional. Please make sure that whatever email ID you give here, you have immediate access to it because an email would be sent to it immediately for the confirmation. Are there any questions either on Discord or the chat window, Kavita and Mandar? Are we good until here?
I don't see any specific questions, Helen. Good now.
Okay, so for those, you can also follow these instructions in the DevCloud handbook that is already it is available on Discord as well as in the chat window. Please make sure you can refer to that as well. So once you click on the next button, you will get this option for about the details on all the company information, etc. So and then you submit. Please make sure that after you submit, you check your email and ensure that you have received the email with the login ID and the email address. Make sure that you have received this email. Can I have a quick show of hands as to? I will just pause here for a few 2 to 3 minutes, just to make sure that all of you are with me. Can I just have a quick show of hands as to how many of you are here until this stage? Please use the show hand feature, and you can just let me know if you're there with me. And once you have received this email, then you have to register for the the dev cloud. So this is where you have to key in the code that we just said. It's ONE1 small API all caps and 18 August, right? So when you click on the activate, you will activate link. You will get to this particular form. All that you have to do is enter the the country, the region, etc., and then use this code oneAPI 18th August and then submit. So Kavita, how are we
10.
on the, anyone having issues?
No, what 10 I see here, Alan. But there's no specific questions of, if they're stuck in the process or. So you can, so everyone, you can please type in your questions on the Discord channel. If you're stuck in any of the steps, we can help you, get access to DevCloud. But to answer your questions, Ellen, we don't have any specific questions as such.
Okay, all right. So in case you just joined recently, we are just going through the DevCloud sign up process. We also have the DevCloud setup guide in the link in the chat window here, and also we have that in the Discord as well. So please make sure that you use the DevCloud handbook and get access to DevCloud so that you can do and you can get ready and do your hands-on lab in the DevCloud, which is a sandbox environment for doing all your testing and benchmarking. Okay, so you will be presented this screen for accepting the terms and conditions, and then click on submit. So then you will. So from here, probably I will just show you. So Kavita, can you see my screen?
Yes.
Yes.
Okay. So you have this anyway. The link in the when you go to this link, devcloud.intel.com/oneAPI get started. Kavita, we can just put this also in the chat window if they are struggling.
Yeah, it's on the Discord right now. So anyone who has access to Discord can view this PDF. Thanks.
Sure, thank you, Kavita. So most of you should be able to get to this page, get started. And here you would have this option called Connect with Jupyter Lab. Right. So when you see this screen, you just click on the Jupyter Lab, launch Jupyter Lab. So you may not be presented with this because I have 2 logins, but you may have just 1 login. So it will just log you into the DevCloud. You may not get this screen. So I'm just switching between the foils and the on the screen to just show you folks. So some of you may get if the server is not running. I think I may also see this. Okay, your server is starting up. So you may see that launch server. If your server is not running, you just click on launch server, and it will take you to this particular screen. Okay, so can we just check out if there are any issues, Mandar, on the Discord or in the chat window? Are people able to follow the instructions? Any questions?
Yeah, nothing specific. We are answering. No problem.
Okay, all right. So you have to connect with the Jupyter lab. So if you are in this web page, get started with the Intel oneAPI Dev Cloud. You will have to scroll down to the bottom of the page and you will see this connect with Jupyter lab. Click on the launch Jupyter tab and then, okay. It may take a few minutes depending on the network speed that you may have. So just give it some time and then you should be, in this kind of a screen. So I will just stay here just to make sure that all of you are able to get to this point. And can I probably just have a show of hands as to how many of them are able to get to this point so that, we can get on to the next part of the presentation. In the meantime, if someone wants to just follow the handbook and then get to the dev cloud, that would also be great. So for all those who were not able to follow, I just will repeat the process so that you are with us. So you have the link that is posted in the chat window and Discord. You click on register, you enter your personal details, name, email, password, create a password, etc. And then you click on submit here. You will get an email for activation. And then once you please verify your email address by clicking this link. When you click on this link, it will basically take you to this form. All that you do is you enter the code and then click on submit, right? That will take you to the oneAPI and then click on submit. It will take you to the oneAPI getting started page. Scroll down to the bottom and then you will have the launch Jupyter lab. Once you launch the Jupyter lab, you may get, if your server is not running, you may get this, or you may not get this if your server is not running. So, and then click on launch server and then you should be at the screen. So that is where I am currently. Please give it a few minutes, depending on your network speed, etc. It may take a few minutes extra. So I also just want to kind of introduce you to the Jupyter notebook. Sometimes, you may be new to Jupyter notebooks. So what I will just do is I'll just do a quick show of one Jupyter notebook and then say, hey, how you're going to run your lab, right? So I just picked this ResNet 50 training.ipynb. This is the extensions for a Jupyter notebook. So all that I do is I double click this. Don't worry, our team will help you get to this point where you unzip the required files and folders, etc. So I'm just picking a sample Jupyter notebook and then telling you how to run, right? So if you're new to Jupyter notebook, all that you do is there are these multiple boxes, right? These gray boxes. You will see there are several of them, right? So all that you do is you just go inside the box and then either hit this play button or the run button, or yes, you just do a control enter, right? When you do a control enter, it will, when the activity is still happening, you will see a star, and once it is complete, you will see the number appearing back again. So a star is an indication that it is still executing, right? So you have to wait until the first box completes and then you move to the next box, right? So there are essentially these are just a sequence of things that needs to be done for your lab sessions. So just make sure that you don't miss any of these boxes. Go one after the other. Do a control enter inside the box. You can see a star here, right? And so that you know that it's running. Especially when you're doing the training, etc., it may go on for a while, right? It may take 2-3 minutes or 4 minutes depending on your data set and workload. So you will see a star appear, and then you can just move on, right? So you just have to repeat the same step for all the boxes that are there in the Jupyter notebook that our team will guide you with. Okay. Any questions? I just showed a simple demo.
They're on the kernel right now in the lab section. So do they wait for the hands-on session, or they can just select the PyTorch kernel for now?
No, I don't think they might have this folder. So I'm inside the PyTorch workshop folder. So if they want, what they can do is, Kavita, they can just follow the guide. I think our folks will guide them into the copying of the model, etc. Right, the exact folder. So for now, we will just stop here, and then we can get into the theory part. If they are here until this point where they are at the terminal or this screen, right, the Jupyter screen, if they are at this screen, I think we are good. I just wanted to show them how to run a Jupyter notebook just as a demo, so that because if they are unfamiliar with Jupyter notebook, they are familiar. So
yeah,
Aditya,
I think to the
yeah, Kavita.
Ellen, I think to the folks who are asking this question in Discord, maybe they have to wait until the hands-on session. So hold on to that page. I would recommend that to the team who's on the kernel page. So hold on till there until the hands-on lab starts. Thanks.
Yes. So as long as you see the screen that I have here, I think we are good. If somebody is not here, let me know. We will just guide them through the process. Anyone having trouble, please post your questions on Discord. We will make sure that we address your question. So Aditya and Jing, you will basically guide them through the copying process, right, from the GitHub.
Yeah. Okay. Yeah.
Okay.
Yes, Alan. I'll cover in my demo.
Thanks. Okay, Kavita, then I think I am pretty much done. I think I can hand it over to Jain for the theory part. If there are no other questions on the setup, anyone stuck with issues, etc., I can just hand it over to Jain.
Yes, Ellen. I think we will be on Discord to help someone if someone is stuck on DevCloud. We can help those guys. We can pass on.
Sure. Okay, thank you. So I will just stop my screen share. Jain, please go ahead and share your screen.
Yeah. Okay.
See your screen.
Yeah. Can you see my screen?
Jain, we can see.
Okay. So yeah, from this slide, I will introduce briefly about the Intel IA hardware features, and also how these hardware features affect the usage pattern of the PyTorch to achieve better performance. So this is a graph shows how Intel CPU architecture looks like. Basically, for Xeon servers, we have two sockets on motherboard. So each socket you can consider it to be one CPU chip. And so here the right part is one socket of the graph of one socket. So each CPU chip it has several cores, and also it has onboard cache. And also for CPU and the CPU communication, we have Intel UPI. This is interface. So this is a bus which takes account of the data communication between these two CPU chips. And also each CPU has its own memory. So this I will introduce later. So basically, for the Intel Xeon architecture, on one motherboard, we have two CPU chips, and each CPU chip is attached to its own memory slots, and the CPU communicates with another one, with its counterpart, via Intel UPI. Okay, so we call this kind of architecture to be the non-uniform memory access, short for NUMA, NUMA. For traditional architectures, the processor is attached directly to a bus, and all memories are also attached directly to the bus. So you can see that on one bus, we have several processors, so as the CPU processors that we say. And also the memories, all of the memories are attached to this bus. So this architecture called UMA, it's the uniform memory access. The disadvantage of this architecture is that the bus will be very highly occupied for data transmission. So this could be a bottleneck for the performance. To solve this problem, the NUMA architecture is introduced. So still we have this bus, but all of the memories are split into several parts. So each part is attached to one processor. So we call this memory as a local memory to this CPU. So in NUMA architecture, we have local memories for all of each processor. It is not that let's say this processor can directly access its attached memory, and also it can access other memories via the bus. So it is not say that if we attach memory to one processor, the processor cannot access other memories. They can, but it will go through the bus. For local memory, it is a direct access. So this, so we call if this processor accesses its local memory, then we call this as a local memory access. If this processor accesses other memories, then we call this as a remote memory access. So obviously that the local memory access is much faster than the remote memory access. For using for the usage scenarios on Intel Xeon servers, we need to avoid remote memory access as much as possible. Also, a data type is a second biggest component of the hardware architecture. So for FP32, it is simplified for float 32. It is stored as like in this format. So it has 1 bit for the sign signature for sign, and then 8. So if this is set to 0, then it shows this number is a positive number. If this bit is set to 1, then it is a negative number. And then followed by 8-bit exponential part. This shows for the exponential part. And for FP32, the rest of 33 bits, Mantissa bits. So this shows for the decimal part. For bfloat 16, because we need to consider the compatibility to FP32, we keep the same for sign bit, the same bitwise for the exponential part, and we use only 7-bit for the Mantissa part. So for the float 16 data set, for float 16 data type, they use 5-bit for the exponential part and 10-bit Mantissa for the Mantissa part. So FP16 could have a relative higher precision compared to the bfloat 16, but the compatibility perspective, bfloat 16 is much better than the FP16 if we take the float 32 as the base. And for int quantization, for int 8, it is 1 sign bit with 7-bit for the Mantissa, so each one. So for int 8, there are 8 bits. The FP32 is usually the default training and inference numerical precision. This is FP32 generally is the base data type. bfloat 16 shown here, it provides virtually the same accuracy for training and inference as FP32. It's simulated on various workloads and achieves virtually the same accuracy. And there's no hyperparameter change required for FP32 workloads compared to bfloat 16. So there are some specific hyperparameters required to use FP16 for training. And int 8 shown here. It provides similar accuracy of inference as FP32 for various of models. VNI instructions is a instruction set which is designed specifically for deep learning workloads on Intel Xeon platforms. So it supports int 8 and bfloat 16 dot product operator. On Intel Xeon, the second generation of Intel Xeon scalable processor, which is the product code is Cascade Lake. The VNI instruction set was introduced as part of AVX 512 instruction set. So the Cascade Lake has 4 channels for int 8 peak computation compared to the float 32. And in Xeon, the third generation of Intel Xeon scalable processor, which called Cypher Rapid or Cooper Lake, the bfloat 16 instruction sub-instruction set of AVX 512 was introduced. So it has 2 channels for bfloat 16 peak computation versus the float 32. The right side is a illustration of the bfloat 16 dot product this new instruction for the bfloat 16 and the DPB USD. This is the new instruction specifically for the int 8 dot product. So originally we need to use several instructions to do the bfloat 16 and int 8. But with these two, by taking advantage of these 2 instructions, we can just use one single instruction to do the computation. So we can achieve performance boost. OneDNA is a library that was designed specifically to accelerate the performance of most popular, most widely used deep learning algorithms or operators. So OneDNA provides the cross-platform performance boost on Intel Xeon servers, on Intel graphics cards, GPUs. So OneDNA support convolution, deconvolution, the inner product, RNN, like the vanilla RNN, the LSTM cell, the GRU, and also it accelerates the GEM, the matrix multiplication. So for the memory bandwidth limited operations, it supports the pooling operation. It supports the batch norm, some kinds of normalizations, and also it supports the element-wise operations, binary element-wise operations like the ReLU, the activation functions. Also for the softmax, concave, shuffle, it also all of these operators are supported in OneDNA. Because we have, so Intel architecture has its favorite data type. The memory layout for storing the data. The NCHW, NHWC used for used in TensorFlow and PyTorch is not always the best data layout for Intel architecture. So in OneDNA we have some best tuned data layout which has best performance on, very good performance on Intel architecture. So OneDNA has a functionality to reorder the data from the external NHWC or NCHW into its internal data layout format. So it will handle the reorder conversion from and to external and the internal data layouts automatically. Then I will introduce Intel optimization for PyTorch. So what is Intel optimization for PyTorch? It is a mixture of, it is a combination of stock PyTorch and Intel extension for PyTorch. We call this Intel extension for PyTorch IPEX, short for IPEX. Optimization for PyTorch, Intel regularly upstream our optimizations, or let's say most of the CPU optimizations to stock PyTorch, so that users can directly have best performance with the PyTorch that you installed in normal in your normal way, like via conda or installed in pip. But there are some specific optimizations or further optimizations which has not been merged in stock PyTorch. So we provided those kind of optimizations in Intel extension for PyTorch, which is called IPEX. So basically speaking, Intel optimization for PyTorch equals stock PyTorch, which includes upstream CPU optimizations plus Intel extension for PyTorch IPEX. So both stock and stock PyTorch and IPEX are combined into one package called Intel optimization for PyTorch, and we made it available via multiple distribution channels through Intel oneAPI AI Analytics Toolkit. So if you install AI Analytics Toolkit of oneAPI, then you will have both of these two binaries by default. Alternatively, you can. We also released the Intel extension for PyTorch as a wheel file, as wheel files. So you can install this separately rather than use AI Analytics Toolkit. So if you install this IPEX wheel file, you will also get IPEX and the stock PyTorch installed automatically. So PyTorch is a open source machine learning library based on Torch library, which is used for applications such as computer vision or natural language processing. It is primarily developed by Facebook, and it is free and open source software under modified BSD license. Although the Python interface is more polished, you can also use the C++ interface for the deployment. So similarly, we also provide Python interface and C++ interface for IPEX, Intel extension for PyTorch. Here we will show a simple usage of PyTorch. So how PyTorch code looks like. Normally we will first need to import torch and then import torch.nn as nn. Then we need to define a model. It will be inherited from the nn.module. And inside this definition, we will define an IIT init function. And we define the some operators here, like we will use convolution comp2d, and we'll use softmax. Then we need to define a forward function. Forward function is the main function during the training and the inference. So in forward function, we put the input this data parameter. This is the input data. We put that into the comp2d operator and then get its output. Then we put its output into the softmax for the computation, and then we return the output of softmax as the output of this model. So when we do the inference, we need to first get the input data, and then we instantialize this model class, and then we put this input data into this model and then gets the final result. So this is the default usage pattern of PyTorch. CPU optimizations are upstream to stock PyTorch, so you can enjoy the vectorized kernel for Intel AVX2 or AVX512 instruction set. And also the OneDNA had been integrated into PyTorch, so you can also, even you use the stock PyTorch, you can get acceleration by OneDNA. The support of NHWC, the bfloat16, the int8 has all been merged into stock PyTorch, so you can also use this data types and memory layout in stock PyTorch. So Intel extension for PyTorch, short for IPEX, is a buffer of PRs for stock PyTorch. It provides users with the up-to-date Intel software and hardware features. And also this IPEX will unify the user experience on Intel CPU and GPU. Currently, there are two separate branches, but later in the future, we will merge them together. So for users of IPEX, you can get performance boost on both Intel Xeon CPUs and Intel GPUs. So we have several optimization methodologies in IPEX. The topology looks like this. So the core part is PyTorch. We use PyTorch as the base and then applied several optimization methodologies like optimizer, operator optimization, or mixed precision. Use these methodologies to implement the Intel extension for PyTorch. So in IPEX, we have the operator optimization, which involves some customized operators. And also, it can do the automatic graph optimization. So maybe you have known that the stock PyTorch, the default usage scenario is imperative mode, which means when you execute one operator, you don't know the next operator. Like when you run convolution, you don't know the next operator is whether it is a batch norm or it is a ReLU. So from performance perspective, we have to optimize individual operator to achieve better performance. But we cannot have higher level optimization methodologies. So the graph mode of PyTorch is it provides the functionality to, let's say, scan the entire topology first, so we can know, okay, the convolution is followed by batch norm and then followed by ReLU. So we can have a high, bird view of the entire topology. With understanding the entire topology, then we can apply further optimization methodologies, like we can do operator fusions, because for deep learning operations, there are several patterns which are most widely used, like convolution followed by batch norm, or convolution followed by ReLU, or convolution followed by batch norm and then ReLU. So most widely, these patterns are used. So we can consider to fuse these operators, like 2 operators or 3 operators into a single one, to reduce the overhead time between the operators. So with this methodology, we can have further performance boost based on the single operator optimizations. For the mixed precision part, we accelerate the PyTorch operators by low precision data types like bfloat16 or int8, and we also simplified the data type conversion, because from converting from the float 32 to bfloat16 or int8 takes extra efforts. So with IPEX, we can do this automatically. So simplify this data type conversion. Furthermore, we have the optimizer. So here, the optimizer is not from the performance perspective. It is for training, like ADAM, SGD. So we also optimize these training optimizers in IPEX, like we introduced split optimizer, and also we have some fused optimizers inside IPEX. We provide easy of use IPEX user interface API for Python interface. So what you have to do is just first import Intel PyTorch extension, this Python module, to register IPEX optimizations for operator level and graph level into PyTorch. If you need to use bfloat16, then you need to call this IPEX.enable auto mixed precision function and set the mixed type to torch.bfloat16. With this single API function invocation, the IPEX will do the automatic mixed precision computation with bfloat 16. So the automatic data layout conversion will be enabled by default. If you don't use bfloat 16, or if you use bfloat 16 and you use float 32, you can what you need to do is just invoke the toXPU function on both the modules and the input tensors to run the code in with IPEX optimization. All the IPEX optimizations are implemented on XPU rather than the PyTorch vanilla CPU. So here is the diagram that shows how IPEX XPU integration integrated into the architecture. So the top is the PyTorch level operators. So PyTorch provides the torch script to do the JIT graph. And also it provides the A10 operators, A10 library for deep learning operators. And also there are some device specific runtimes defined in PyTorch. So IPEX use this interface provided by PyTorch to provide further optimization for the graph integration, for the kernel level optimization with OneDNA or OneCL. And also we provide XPU device. We register this XPU device into the device runtime, PyTorch device runtime, so that the optimizations will be applied. For GPU, we use zero device runtime to maximize the performance on Intel GPU hardware. So this architecture works for CPU, GPU, and other hardware accelerators. From the software user perspective, the code change to the original PyTorch code is very simple. First, you need to import Intel extension for PyTorch, Intel PyTorch extension, and then again, just to define the module as you have to do for the PyTorch. Then after you initially get the input data, just call .toXPU function on the data, and also apply this toXPU function on the module. So if these two steps are done, then at the final line model input, this inference will running into Intel optimization for PyTorch, where you use all of the Intel optimization methodologies. From graph optimization perspective, as I mentioned that we can do operator fusions to reduce overhead for memory operations furthermore. In IPEX, we have the batch normalization folding. So which means if you run convolution 2D or you run convolution plus batch norm, then the batch norm will be merged into convolution. So it will reduce the operation execution time. And further, if you use this convolution plus BIOS plus add or plus ReLU, or you use convolution plus ReLU or LU, this kind of activation function, or linear plus ReLU, all these kind of patterns will be merged into, will be fused into single operator, which brings performance boost furthermore. Yeah, by reducing the overhead. For other operators, there are users for, if you use PyTorch, you are always able to create your own operator rather than just use the A10, the PyTorch A10 operators. So for some most widely used topologies like mask CNN or SSD ResNet 34 or DRM, they are customized operators. So we have also implemented these operators in IPEX. So if you run this, you can directly replace the original customized operator with the optimized one in IPEX. For the training part, if we train with, because the bfloat 16 has lower precision, so its performance is accelerated compared to FP32. But the problem that we have with bfloat 16 is that compared to FP32, the accuracy is lower. So because it has less bits for the mantissa part of the data, float data, so the accuracy is relatively lower than FP32. For training part, for training a model, the biggest problem, the biggest thing that we focus on is the accuracy of training. Compared to performance, training accuracy is always the first priority. So to overcome this low precision issue brought by bfloat 16, we still keep the float 32 weights in memory. So let's say if you run training with bfloat 16 like this, the input is bfloat 16, the weight is bfloat 16, the BIOS is bfloat 16. So if you do the forward pass for the inference or the forward pass, then this is okay. But if you need to do the backward propagation later in training part, the stochastic gradient, this SGD operator, the optimizer, will still use one copy of FP32. So FP32 copy of the weights, original weights. Let's say to make sure that there will be no accuracy loss brought by the FP32. So this is called the split SGD. This is one optimization methodology that we used in IPEX to run with FP16. To make sure that we keep the accuracy of the training, but we still enjoy the performance boost with the low precision data type. Okay, now we are coming to the poll. So could you show the poll screen that we can ask the Oh, okay. Hi, Lakshmi, are you still seeing my presentation window or the poll window?
Hey, Jinsan, I can see the poll.
Oh, yeah, the poll is up. Poll is up, yeah.
Thanks.
Yeah, so the question is which components are included in the Intel optimization for PyTorch. So we have A, B, C, D for choices. So let's see how we should choose from these four.
Jain, you can also see the responses of the poll in the control panel if you'd like to analyze. Yeah.
So, Jinsan, I think 15% have opted in for Intel extension for PyTorch, and 85% in C both. Yeah.
Yeah, I see 58% has been voted. So, okay. Yeah, let's wait for a couple of minutes. Okay, so yeah, I see that 72% has voted, and among which the 80% chose the both of above. This is the correct answer. So as I introduced in the previous slides, the Intel optimization for PyTorch actually contains the stock PyTorch because we are always upstreaming our Intel optimizations to stock PyTorch. And the rest of the optimizations, which is pending on the merge, PR merge, or some specific optimizations are implemented in Intel extension for PyTorch. So the answer of this question is C. It includes both two components. Okay. Okay, so let's continue. You all see my screen or the poll window?
We see the screen.
Oh, okay. Okay, so yeah, I will show some case studies of the usage of IPEX, Intel optimization for PyTorch, to show its performance boost. So here is the result of one training example with bfloat 16. We conducted this training on the third generation of Xeon scalable processor. So we used three topologies. One is DRRM, Facebook DRRM, and another is the BERT large. The third is the ResNext 101 with 32 by 4D topology. So we run one instance for training. So here the second column, we run one instance for training, and each instance uses 28 cores. We compare the performance with between FP32 and bfloat 16, and we can see that the performance boost that brought by bfloat 16 is around 1.55 for DRRM, 1.81 for BERT large, and over 2.4 times better performance for the CV computer vision task. And also, meanwhile, we tested the bfloat 16 with the inference workload. Again, the topologies are these three. So we ran it with 224 instances, and each instance will use only one core. So we run it in a throughput mode. So we simultaneously we run 224 instances, and we can see that as the result, the bfloat 16 achieved 1.4 times better performance compared to FP32. Yeah, similar number for the BERT large, and again over 4 times better performance for the image field for ResNext topology. So if you are interested on these numbers, more detailed information are provided in this blog, so you can open this and learn more from this article. For the int8 topology, int8 data type, we conducted another workload with DRRM So we run one instance of the DRM and use 28 instances. We run 28 instances, and each instance use only one core for the inference. This is the number that we got for int8, and this is the number that we got for with FP32 data type. Comparing these two, we can see that we achieved 2.85 times better performance with in quantization with int8. Also, this table, more detailed information of this experiment can be found in this article. Okay. There are other two case studies. One is a topology called used fast speech and multiband Melgan topologies, which are provided in ESP.NET. We used no more than 3 cores. We used actually 4 cores for one instance on this workload. Originally, we didn't get performance, ideal performance, so we used PyTorch, the PyTorch PyTorch profiler, default profiler, and this is the table that we shown. We see from the profiler. So we can see that this operators are sorted based on its CPU, its execution time in descent order. So the top one is took the longest time, but since it is convolution, this has already been optimized by Intel with Intel optimizations. So we focus on the second, the top 2 operator, and we see that it took around 12% of time for the duration for the computation, compared to the third one. It's twice long. So we did some investigation on the unsqueeze, this unsqueeze operator, and then applied some further optimizations. After this analysis and the corresponding optimization, we achieved performance boost with our optimizations. And another workload is a OCR model. So this model, this workload converts the image, finds the text strings inside the image with PyTorch. We tried because by default the PyTorch use GNU OpenMP as its OpenMP backend, but at the same time Intel has Intel OpenMP library. Sometimes Intel OpenMP library could achieve performance boost, and also there are third-party memory related, malloc related libraries like JMalloc or TCmalloc. With these 2 malloc libraries, they optimized for the cache, the memory cache usage. So from memory usage efficiency perspective, the JMalloc and TCmalloc sometimes has better performance. Could result in some better performance. To use these third-party libraries are very simple. We just need to use the LD preload, this environment variable, to load them, and then everything could work. Also, JMalloc and IOMP had some their specific environment variables like KMP affinity, KMP setting, KMP affinity, the malloc config, the KMP block time. So without using them, these libraries, with the default PyTorch libraries, we can see that less than 90% of the CPU time was used. And also we see this long red part. So this indicates that there are some low efficiency operations were running inside Linux kernel. So after the code, after the we applying this libraries, we running it with PyTorch, we can see that the CPU usage raised to around 100%, and also we reduce this red part. We don't see the red part in this running, so it means that the execution efficiency is much higher than before. So with these two methodologies, we again achieved performance boost compared to the previous rounds. So to summarize, the stock PyTorch profiler helps us a lot to do to understand where is the hotspot of our codes, and so we can take actions to reduce these overheads. And also, if we apply other libraries like IOMP, we switch the GNU OpenMP to IOMP, or we apply the JMalloc, TCmalloc. We can also, it is also possible to achieve performance boost compared to the original one. So here is the a flow that we provided in AI Analytics Toolkit. So in AI Analytics Toolkit, we not only have the Intel optimizations for PyTorch, Intel optimization for TensorFlow, we also have OpenVINO Toolkit, which was designed specifically to accelerate the inference part of deep learning. Also, the traditional machine learning, the classical machine learning tasks are also included in supported in the AI Analytics Toolkit. So depends on your workload, how you would like to run your workload. There are several usage models that you can consider. So first, if your workload is about the data analytics, like data preprocessing, so you can use the data analytics related softwares in AI Analytics Toolkit, like Pandas, the Intel optimized optimizations for Pandas, NumPy, SkyPy. If you would like to accelerate your classical machine learning workloads, then you can use the Intel optimizations for scikit-learn, for XGBoost, and also DAO, the Intel-specific deep machine learning acceleration library provided in the AI kit. For the deep learning part, if you would like to implement a framework like TensorFlow or PyTorch, let's say, if you are not satisfied with TensorFlow or PyTorch, you would like to write your own framework, then you can consider to use OneDNA or OneCCL as the acceleration library. If you would like to do the training, or if you would like to do training with your model, then you can use the Intel optimization for TensorFlow and the Intel optimization for PyTorch in AIKit. Yeah, it's the same for the fine-tune. If you want to retrain or fine-tune a model with customized data, then you can also choose TensorFlow and PyTorch in AIKit. If you would like to do inference only, if you would like to do inference, or if you would like to use a pre-trained model that is optimized by Intel, then you can use the AI kit, AI model zoo, and see if the topology, the model can be converted to OpenVINO format or not. If the model cannot be converted to OpenVINO, then you still need to use framework, TensorFlow or PyTorch for the inference. If the model can be converted to OpenVINO and the performance shows better, then you can choose to do the conversion first to OpenVINO format, and then use OpenVINO inference engine to run it on dedicated devices. So you can choose which device to run, or to run on CPU, or you can choose to run on GPU or other acceleration libraries. Okay, here comes to another poll. Yeah, let's switch to the poll window. Okay, the question is, which data type is supported in IPEX, in Intel optimization for PyTorch? Yeah, I see around 60% has voted. Okay, so yeah, majority of the votes are on D, all of the above. This is the correct answer. Because yeah, in IPEX, in Intel optimizations for PyTorch, we include all of this data layout for int8, for int8, for float 32, for bfloat 16. Yeah, all of these data types are included, are supported in Intel optimization for PyTorch. Okay, so yeah, so let's move to the hands-on lab. I will change the screen to Aditya.
Yeah, Jain, if we want to take a 5-minute break, we will probably start in 5 minutes.
Right.
If people want to take a 5-minute break, we can just give them a 5-minute break.
Yeah, let's take a break.
Yeah, we will. So we are at 11:13 India time, 11:13 India Standard Time, Indian Standard Time. We will start exactly at 11:20 IST, Indian Standard Time. We have 6 more minutes to go. We'll take a short break. Kavita, is that okay?
Yes, Alan, we are good. Thanks.
Okay. In the meantime, if any of you have any questions that need to be addressed, or any doubts you have, you could just post it on Discord. We can help you with the answers for those questions.
Yes, and for those of you who still want the DevCloud access or the lab file, it's pinned on the Discord channel. So go to the pinned section and download these files.
So Jing, there is one question on Discord related to the batch training optimizations and overfitting problem. So I see that some of them are already catching up with the labs. So thank you so much for your active participation. We'll just give a few minutes for the rest of the folks to catch up. Jing, are you there? Kavita, can you hear me?
Yeah,
Ellen, I can hear you.
Yeah, I think okay, maybe Jing is on a break. Okay, let him come back.
Okay.
So Aditya, you can just get ready. You can start sharing your screen. In the meantime, let others just join. Sure, I think let's just have a quick poll and see how many of them have actually logged into DevCloud. That's a good point. Yeah. Can we have a quick poll just to check how many of them have logged into DevCloud and they are able to start on the exercises? Can we just have a poll? Before we start, we just want to make sure, it is good to check.
Pradeep, do you think we can repeat the poll number 1?
So
Yes, Kavita, 1 second.
Sure.
Jing, are you back?
yeah, I'm back.
I don't know. Okay, so there was one question on Discord related to related to batch training, how it optimizes the overfitting problem.
Could you put that in the chat window?
Yeah, I'm just putting. Yeah. Okay, we can see your screen, Aditya, now. yeah, Jing, I have put the question. How come batch training optimizes overfitting problem? Can you please explain? I'm not able to follow the same with respect to SGM.
Oh, okay. So yeah, our optimization are focusing on the performance optimization. So not for not for solving the overfitting or those problems. But of course, from the accuracy perspective, we will make sure that while we achieving better performance, we will still keeping the accuracy. So does this answer the question?
Okay, let's just check.
Should I relaunch the poll, Kavita?
Yeah,
Yes,
just
please.
give a second. Ellen, I think he wants this to be repeated. Jing-san, could you repeat the answer, please?
Yeah. So our optimization focus on the performance perspective. So we will not directly touch the accuracy part. So our target is to we will make sure that while we achieve performance boost with Intel optimizations, we will still keep the training accuracy loss.
Okay, thanks. Thanks, Jing. I think the focus is more on the performance than the accuracy. That's what Jing's response is. I don't know. Did that answer your question? Please, Nama. Okay. All right. Can we have the poll on screen, please? Okay, we can see that at 85% of you are at yes. Can we have the rest of them also vote, please? We see that 50%, almost 55% have voted. If we can have the rest of them also just confirm, that would be great. I hope all of you are able to sign into and register to DevCloud. If you could just let us know, that would be great.
Yeah, and if you are facing any issue, you can post on Discord channel.
Okay, so yeah, 62% have voted and almost 85% are saying yes, Aditya.
Oh, okay. So almost 50%
Yeah,
registered. Yeah. Okay.
Okay, so, you can go ahead.
Okay, sure. So if you have logged in, and I think most of you will be seeing this screen after login. So from this PDF of the instructions, you can open this and follow and copy the instructions from here. And on DevCloud, first of all, like you need to launch the terminal from here. So in the top left, this new launcher, you will see all these kernels and these tabs. So here you can open the terminal by clicking on that. And on the terminal, we need to like follow the instructions from this PDF, and I'll be also going through all these instructions. So first, like we are downloading all the data set and notebooks by cloning the repository. So okay, it's taking a little. Okay, so now like we have this PyTorch workshop folder in our home directory, so we can check. Okay. So now we have cloned our the folder which is having all the data set and notebook, and now we can just you can check it with like ls. So you can see PyTorch workshop somewhere. Okay, so you can see this folder created, PyTorch workshop, and you can now we need to go into this folder by just cd PyTorch workshop. And we will be able to see these two zip files, ResNet50 inference and ResNet50 training.zip. And now we need to unzip both of these files. So you can follow this unzip command. And similarly for inference also, we can unzip. Now we should see these two extra folders unzipped, and okay, so after this from the left we can open our PyTorch workshop folder, and then now we are going to start with PyTorch ResNet50 training one. So let's open this one and the training notebook. Just double click on the notebook, you'll be able to open that. So here you should be able to see PyTorch kernel, PyTorch 1.4.0. Actually, it's a newer version, but the name of the kernel is little like different. It's not correct, but we are using the latest version of PyTorch here. Okay. So if you are not seeing this kernel, you can click on this, and you can just click on this and then scroll down and select this one, PyTorch 1.4.0 AI Kit. And
Aditya, for the benefit of others, maybe what we could do is, maybe you can just repeat the steps what you showed until now, just to make sure that people are with us. We will also just check the Discord. If they're stuck anywhere, we will let them know. You can just repeat the steps that you have done till now on the terminal, as well as how you open the notebook, so that people are able to follow.
Yeah, sure. So for launching the terminal, just need to click on this plus button here. It will launch the this page, and then you can click on the terminal to open the terminal for you. So here you need to like copy all the steps from this PDF. I think this PDF has already been shared on Discord, or did we share on here also on the chat?
Kavita, is this
sent
PDF
it on Discord. So it's on Discord.
Okay.
Looks like we can't insert a file on the chat window here or go to webinar.
Okay. So Aditya, is there a direct
Okay.
link to this from GitHub? If we have a direct link, we can also put that in the chat window. We will check that.
Can you attach these files to the notes section?
I can add like a PDF file as a handout.
Okay.
Yeah, this is a PDF
Okay,
file.
sure.
Yes, that
Pradeep, let me send this to you quickly.
Sure, Kavita.
Okay, once you have launched the terminal, we need to just follow these setup instructions one by one. So the blue highlighted ones are the scripts we need to copy and paste in the terminal. So I have cloned the repository and then unzipped all these both of these folders, and yeah, I'm here. Like I've opened the training notebook. So let's wait for 1 more minute, and if you have any questions, you can post Discord.
Yeah, is everyone caught up on the with the process? Saurav, are you with us? Are you able to follow? Okay, all right. So right, yes. Okay, Aditya, we will help out Saurav. We'll help out Saurav. Don't worry. You can proceed.
So Alan, the file is on the handout section, so the participant can download the file.
Okay, even on the GoToMeeting, right? GoToWebinar.
Yeah.
Okay, thanks, Kavita.
Okay, so once you have like opened these notebooks, we don't need the terminal now. We can just run through these notebooks. So this one, ResNet 50 training notebook, is basically for training our ResNet 50 model. So what we are doing is, we are not doing full training here of the ResNet 50. We are just doing the last dense layers part training, because if we do the full training, it will take so much time. So for the training part, we are just doing the last few layer training. And this use case is basically classification of our image into two classes. One is the alien and other is predator. So you can see these left two are alien images, and right two are the predator images. So these are the images we have taken from the data set itself. And this data set and the baseline of this notebook is present on this link. You can check more there. So in this data set, we have like 347 images, training images for alien category, and 347 for predator category, and 100 images for each of these classes for validation. So this was about data set, and let's go through all of these cells and run them. So here, like we are importing all the like record libraries, common libraries, modules. So let's import them. So NumPy will be needing, and by matplotlib and time and PIL. So we have done this, and then PyTorch specific modules we are importing. So torch, and then from torch vision we'll be like importing the ResNet 50 model, T10 model. So yeah, this one models, data sets and transforms for data manipulation and data creation. So, and then we are importing neural network, one from torch, and then other it's neural network functions, and then this optim for optimization or updating the weights. This will be used for optimization of the weights. And this one is the module which we needed for IPEX. So with the use of this, we will be able to use our IPEX optimization for normal PyTorch. So here, like in the normal PyTorch model or notebook, we just need to add this import line. So I think I have done this, and here we are like generating the data set and transforming it. So so we are like this. So since the images are of like different size and dimensions, we need to do this. We need to resize it to 224 by 224 and then convert it to tensor and then normalize. So we are doing this for both training and validation. So this is just for training we'll be doing this transformation, and for validation we'll be doing this transform. Here both are same, but still like we can change it according to our needs. So this was the defining our data transform function, and here we'll give the path to our training data set and validation data set, and apply the transform function to all the images we have. And then in the data loader we'll get the our data set into our tensor, and which we can use later. So it will give iterated kind of thing which we can take one by one. So here we are taking a batch size of 64. We can change it according to our needs, but here we have picked 64. So I think let's run this, and in this one we are creating our network, neural network. And here, so from models we are importing ResNet 50 model, T10 one. And here what we are doing is basically we are making gradient off for all the parameters, because we are not going to train the full network. We'll just train this fully connected layers in the end. So we are defining that. Since we have two classes, we are just giving two as output. So let's run this one also. It will download the pre-trained model, so it may take a little bit more time. So till now, like we didn't need to do anything apart from this import for IPEX. So it's downloading the model. So when the notebook is running, you can see star mark between these two square brackets instead of this number. So I can see it's completed now. And now we are like defining the loss function, which we'll like backtrack, using which we'll backtrack our error functions to change the weights of the network. So we are defining this cross entropy loss function, and for optimizing and changing the weights, we are using this Adam optimizer. So this is also we are taking from Optim, which we imported from Torch. And one thing to note here is we are only going to change the weights for this fully connected parameters model. So you can see the model.fc parameters. So here we defined this model.fc according to our data set. Okay, so we have defined the loss function and optimizer. Now here we'll see like which device we are on. So CPU, we can select the device as CPU using this torch.device. So this one, and now here's the training part. So here in this function we are taking the model from here, the main model, ResNet pre-trained model, and then this loss function, then optimizer, and the number of epochs. And so this is the difference here with this IPEX parameter. What we are doing is so we can change it according to like what we want to use. If we want to use the IPEX, then we can make it true in our uses of this function. So these are all the parameters, and here we like defining the time, and because we'll check like how much time did it take for this training. So this is the content of the function. What we are doing is we are taking each epoch, and then if it's training, then we'll like activate the training mode of model. If it's validation, we'll activate the evaluation. So it's so initially for each epoch we'll put the weight as 0, and sorry, loss as 0. And now we'll take the input and labels from our data loader, and for let's say this phase is training or validation. So for training phase, it'll take the inputs from our training data set, or if it's validation, it will take the inputs and labels from validation data set. So here this is the main thing. Here we are going to change. So if IPEX is activated, like if
Aditya,
IPEX is true for us.
Aditya, there is a question basically about should we use a separate model for training using IPEX, because I think Indrajit is asking this question. We are already training the weights using the default method, and we are reusing the model object with the trained weights, right? So he's asking, should we use a separate model for training using IPEX, right? So
yeah, like yes, you can do all these changes and use different models later.
Yeah, so yeah, I think probably the answer is maybe Indrajit, feel free to try it out, and you should be able to get similar results, right? So that's what our estimate is. Yeah, feel free to do that, and maybe if you still are stuck, we are there to help. Okay, cool, thanks. Yeah.
So this is the main thing here regarding the IPEX. So since we have all these data set and input data set and validation and all these in our CPU device, we need to if IPEX is true, we need to move it to this IPEX device using this function .to IPEX .device. So this is the thing which will be done when IPEX is true. And if IPEX is not true, then it's already in the device. Its else part is just to show that it's in the CPU device already. So once we have model and input and all the data files in data set in IPEX device, it will use our IPEX optimizations. So here it will calculate the output from our model with the training data set, and then calculate the loss using the labels we have. And if it's the training phase, then we'll get this. We'll put this loss backward and optimize our weights for the networks. So this is the training part, and here we are calculating the results loss function and how many of images are correct or not. So this is for calculating the loss, and so for full epoch, here the loss is calculated, and yeah, this was the part in the training, and here we are calculating the time required from starting our epoch 1 to number of epochs we have. So here we started our time, and we are checking the time till this point, like when our training is completed, and we are storing this in t time. And so let's run this function now. And now what we do is we'll use this function, whatever we defined here, for our IPEX false and IPEX true. So we'll store the time required for the training with IPEX false in the DUR underscore n, and with IPEX true store in DUR I underscore I. So it will take some time, and we will be able to see the results. So it's initially it's using our normal PyTorch. So right now epoch 1 is going on, and in this cell, what else we are doing is we'll see how much better IPEX training is and the speed up. So let's wait for this. So as also we can see loss is decreasing as the epochs as we go further in the epochs. Since initially we were having 0.44 loss and accuracy 0.78, and after the training has been done and the weights been updated from after the epoch 1 till now, loss has been decreased and accuracy is increased a little bit. So yeah, this is how like training is going on now. Again with epoch 3, again loss decrease and accuracy increased. So we are not like worried about loss and accuracy right now, because we are just comparing the IPEX and normal PyTorch time for training. So training with normal PyTorch is completed. It took 2 minutes 25 seconds, and with IPEX it's now started.
Just wanted to check how others are doing. We do see a few of them are able to kind of progress on the hands-on sessions. If you are struggling or are not able to keep up, feel free to just post your queries and make sure that we are able to help you, please. So at least we have seen 3 or 4 people already post their results out in the Discord. So thank you so much for doing that. And others, I know Saurav and others who are probably not had some issues. In case you have still some issues, please let us know.
Yeah, so for my case it's completed now, and we can see the training with IPEX took 1 minute 27 seconds, and with PyTorch, stock PyTorch, it took 2 minutes 25 seconds. and if we increase the epochs also, we'll see this kind of time reduction, and it's scalable. So
I think that was one question. That was one question in Discord, Aditya. So probably what I think it was Indrajit who felt there were probably IPEX could need a little bit more number of epochs. So yeah, so you may want to just add on to
that. Yes, so even if you take like more epochs, you'll see such kind of accuracy increase. So sorry, performance increase and speed up. But it depends like what batch size you are picking and all these hyperparameters also. So for training, this is the case. Like according to our hyperparameters, it may change, but still like you'll see like from our experience, we see at least 1.5 or 1.5x speed up at least, mostly.
Yeah, especially given that this is a very small workload, right? For training, typically the data sets are so huge, and it takes hours and hours of training, either it's on the cloud or on your local machines. So just imagine maybe a 30 to 40% decrease in the reduction in the time for training, right? It's going to be huge.
Yes. So now, so this notebook, I've also like added the inference part also with the same data set. So because it's quick, we can go through it also. So here we don't need anything like optimization, like because we don't need training related things like calculating the loss and updating the weights, so we don't need criterion or loss criterion or optimization variables here. So here just we need the model, the pre-trained model, and the IPEX if we want to use IPEX or not. So for inference, again the time, we are starting the time and then activating the evaluation mode of the model. Then here also we'll calculate the loss because how much accuracy and how is the loss with validation data set. Again the same things like if IPEX is true, we are using this IPEX device, and if not, the device is already used. So yeah, here we are calculating the outputs for all the input images and the loss, yeah. So similarly for each epoch, we will calculate the loss and accuracy again. Only thing is like we don't need to update the weights. So again we'll see the time, how much time it required to do all this inference part. So let's define this function by running it. And now similar to the training notebook comparison, training time comparison, we are doing inference time comparison for if IPEX is false or IPEX is true. So it will be very quick for both IPEX false or true. Yeah, so we can see inference time with stock PyTorch. It took 14 seconds. Here we had 100 images for alien category and 100 for predator. So total images were 200. So it took 14 seconds to get the results from our model. So it is inference time with stock PyTorch, and it took 6 seconds with IPEX. So yeah, we can see like almost 56% of decrement in time which was required for this inference, and yeah, more than like 2x of speed up. So this was the inference part, and here like we are using just trained models to get the results for some sample images from our data set. So yeah, like we can see here for this image, it's alien and it's predicted 100%. So it's like very ideal case. For here also, it's alien. It's in the alien category. We can see here. So validation alien. So it's model predicted like correctly almost. So 82% probability of being alien it predicted. And here also like almost ideal case predicted predator. So this was like full training and inference notebook, and we have another notebook which has like some custom images, and we'll be using the inference 50 pre-trained model again to infer for those custom images. So again, like we can go to this PyTorch workshop folder and then open Resident 50 inference folder and just double click on Resident 50 inference notebook. So you will see like this PyTorch 1.4.0 automatically selected. If not, you can just click on this and select PyTorch 1.4. So here we have we have all these 6 images we have taken from some sources like on internet, and we have put this data set into like 3 category. So this one is for fish category, and these 2 are for car category, and this one this is like some other animal. It has some ID. So here basically the ResNet 50 model is already trained on ImageNet dataset. So we are not doing anything else. We are just we have taken these images, custom images, and we'll do the inference. And in ImageNet dataset we already have some ID for each object. Like for fish, we should be having some ID in ImageNet dataset, and for car also we have some ID to differentiate, and for this also like we have some ID. So let's run this inference. It's pretty straightforward. Just no need of training or anything. Just the same thing we added here. Import Intel PyTorch extension on IPEX, and we are just using the IPEX in the function. So what we are doing is we are transforming the input images and preparing our data loader, and here we are like getting our pre-trained model ResNet 50, and we activate the evaluation mode of it, and we are using again the same thing that we did for the other notebook. Just did the 2 IPEX device, so it's now available in the IPEX device. And again, like what we are doing is, since these are like very few images, 6 images, so we are doing this for like 10 times. We are doing the inference with 10 times, and then we'll average them. So here we calculated all the time required, and here I took batch size of 3. We have 6 images, so any batch size is fine. Just so let's run this and define this function for inference, and here we can see the similar comparison of time required for the inference of with IPEX and without IPEX. So let's run this also. So again, this will take some more time because we had like not many images, but we are doing inference multiple times on the images. So you have to wait for some time here. Meanwhile, like I can check.
So I know many of them have been sharing the results. When you are sending an email to Kavita, please make sure you attach the screenshot as well as the actual numbers that you get on the text, right? You can just copy or take a screenshot of both the bar graph and also the actual numbers that you get on your screen. It will be good so that we can correlate it along with the code.
So it took like 186 seconds but there's a mistake here. Like we have added this M. So you can just assume or edit this MS to S. So second. So it's still fine because we are consistent with both of these IPEX or without IPEX. So here what happened is we had like 2 batches, and as we can see in the images data set we had three images for one category, that much fish. So it had the ID 0 in image data set, and one was for this animals image, so it has 336, and for the last one of car we had in ImageNet, it should have 511 as ID. So we can see like results are consistent with and without IPEX, and the time taken here we can see. So here it took 186 seconds for the inference, and here with IPEX it took 89 seconds. So it's again like more than 2x of the speed up. And with this notebook, like you can experiment more and take other data set and check or maybe other model. So this was the inference part mainly. So now I'll move to OpenVINO part also. So Alan, like I'm taking like 2 minutes of break here because I need to set up this.
Yeah, sure.
In my local.
Sure, no problem. Yeah, in the meantime, if there are any questions, etc., please do let us know. So what Aditya is trying to showcase now is, so we did currently we did inference using the PyTorch extensions. So the next demo, so this is not we didn't have the hands-on plan for this. He will just show a quick demo of how OpenVINO can be used to do inference. Right, OpenVINO is a toolkit from Intel, which is used for inference, and we will, let's say you already have a trained model, right, and you are not interested to, let's say, make changes to your code with IPEX, etc., then OpenVINO can come in very handy. You just feed this existing model into OpenVINO, and then it will generate some intermediate representation, and you can use that intermediate representation for doing inference, right? So this is assuming you probably don't have control over the code and you just have the bare model. So in that case, what do you do, right? It could be PyTorch, it could be TensorFlow, it could be any other model. So Aditya is going to show a demo of how you use a ready-made model that you already have, and then do inference using OpenVINO, so that OpenVINO can optimize that model for the underlying hardware, whichever is going to be the hardware. Whichever Intel hardware, it will optimize. So in the meantime, any questions? Yeah, Aditya, yes.
Are you still seeing my screen? No. I'm. You are seeing my screen or not?
Not yet.
Okay. I'm still. Just give me 1 more minute.
In the meantime, is everyone able to get or reproduce the results that Aditya had shown on his screen? At least for those who have shared the results on the Discord, we could see it definitely. But is everyone able to consistently reproduce the results? Okay, see, there's a question on base toolkit and separately install analytics toolkit. Yeah, you can directly install AI analytics toolkit, and it should have all the dependencies covered. So you can just directly install the AI analytics toolkit. But in case you want to do some profiling, etc., then you may need the base toolkit. where you have the profilers like VTune, etc. Right? But if you just want the bare only the analytics toolkit, you can directly use the AI analytics toolkit. And even further, if you want to just install specific components like IPEX or even Intel distribution of Python, etc., you can directly use any of the channels like pip, conda, etc., and directly install just that component, which will also give you the Intel's optimized versions. So question, I think on IPEX library work only on Intel versus Ryzen can also be used. Is that that's the question? So Saurav's question. Saurav, so whatever extensions we have for PyTorch, etc., we have validated that on the Intel CPUs. Typically, we don't guarantee any performance on any other processors, but if let's say AMD or NVIDIA have done some work on this, we can definitely, you can leverage, because for us oneAPI is kind of an open standard. We are just defining the standard, and already we have some part of the oneAPI already working on NVIDIA CPUs, etc. But as such, for IPEX specifically, we don't really guarantee any performance on competitive CPUs. We validate it only on Intel processors.
Yeah. One clarification is that currently the IPEX only runs on AVX 512 machines.
Yeah, good clarification, Jain. Thanks for that. So AVX 512 is one of the instruction set that is needed for the PyTorch extensions to work. So that is available on the Intel first generation scalable Xeon processors. So that is something that's a good clarification. Thanks. Okay, and Indrajit had some question on analytics toolkit based includes analytics. So Indrajit, is all your question answered? Any? Okay, cool. All right. Yes, they are. Okay, all right. So Aditya, are you ready? Are you able to?
Yes.
Okay. We can see
So
your screen.
you are not seeing my screen? Okay.
Yeah, we can see it. We can see it. Yes.
So yes, like for OpenVINO toolkit is basically for speeding up the inference of our deep learning applications, and it supports all the all the main frameworks like PyTorch, like TensorFlow, PyTorch, and MXNet, Caffe. So all of these are supported directly by OpenVINO. But so all these are, but only thing is with PyTorch we need to convert it to OneNX. So that's the thing it has. So we are going to show how we can convert it, because now with the latest version we don't need to do the conversion manually. It's already included in the OpenVINO toolkit. We just need to run the scripts, and it does all the conversion to ONNX, and then use the OpenVINO. So with OpenVINO, like we have two steps. Like let's say we have one pre-trained model of any framework, deep learning framework. Let's say PyTorch model. Now it needs to convert it to ONNX. That's what it has been included in the OpenVINO. And once we have the ONNX model, with the use of model optimizer, it gets converted into IR format. So IR format is basically two files, XML and bin file. XML file will be having all the networks related details, and bin file will have our pre-trained weights for the network. So that is IR part, which is done by model optimizers. So we'll see all this in this demo. So let me show the directory structure of the OpenVINO. So this OpenVINO 2021.4 been installed, and in this one we have this bin data pre-processing deployment tools and all this. So bin is here to just activate the OpenVINO, so that I have already done. It just sets the activate the OpenVINO, and so let's do the inference of ResNet 50 pre-trained model PyTorch. So let me go to this correct folder. So here in the deployment tools, we have Open Model Zoo, and then tools, and then downloader. So we are just going into that, and here we can see all these Python scripts which we can use directly. So the downloader one, let's check this. We can see like how it can be used with H. Oh, sorry, I think I have not activated the environment. So let me do that first. So this is my like a Python environment in which I installed some dependencies, requirements for the OpenVINO, and here like I'll activate the OpenVINO itself using this source opt intel bin setup one. So now OpenVINO is activated. Now we can see like so we can see like downloaders functionality, what it does. So the arguments it is showing. So here we can see if you want to download some pre-trained model available in OpenVINO Model Zoo, we can just give test name, and after that we can provide the name of the model which we are going to use, and print all will show like what are all the models which are available with the OpenVINO. Let me show this. So yeah, we can see like all of these pre-trained models are available with OpenVINO and optimized with OpenVINO. So here we can see like all types of use cases and multiple models for each use case. So this was like how to use the downloader. We don't need to do anything, just Python downloader, and give the name of the model which we want to use. So let's do this step. So we are okay. So we are going to download the PyTorch ResNet 50 PyTorch model. So here also in the list we can see ResNet 50 PyTorch model, this one. So from this list you can download any model from here, and I have downloaded the model, and we can see where it stored the model like this. It will show, and after we have downloaded the model, next step is to like convert this model to IR format, which will be ultimately used by inference engine of the OpenVINO. So let's do this like use model optimizer. So basically in the downloader we have all these converter downloader. So converter.py is used for converting our model. Just we need to provide the model name from the list. So what I have done is
Aditya, quick time check. We have, you can take maybe another
yes.
5 minutes.
Yeah. So for converting our downloaded model to IR format, what we did is basically we used that converter.py file from our downloader folder, and then gave the name of our model, or like the name may not be required if you are doing some custom model, but we need to provide the model, right? So here like mo and it's given. So first it will convert it to, since this is a PyTorch model, it will convert it to OneNX. So all these arguments and script is given. This we can use manually also to convert the PyTorch model to NNX. Since it's a pre-trained model available with OpenVINO, we can do directly. We can use the converter.py directly. So we can see here it converted our model to this XML and bin files, and it is stored somewhere in downloader public here. So we got now XML and bin files, and these files we can use for our inference. Let's say, okay, so we have like with OpenVINO we have multiple demos for different use case. Let me show one of demo for directory. So these are all the demos available with OpenVINO. So these are different use cases. So classification and different object detection, and these are like use cases. And we have like demos also for all these at different place that I think can check later. But let me run one demo here with ResNet 50. So since we have this pre-trained model and we converted it to IR format using model optimizer, now we need to run the inference using inference engine, which is the part of OpenVINO. So this classification sample.async, this is the like a demo script which uses inference engine inside, and we'll run this to check the results from our inference ResNet 50 model. So let me run this. So what I did is basically I had the data set of which was like we used for inference using IPEX. So that's the data set I used. I have like 6 images in that. So what I did is basically there is this script, sample script, classification sample. and then we gave the path to our XML file and the input file here. So we have like 6 images. I gave all the input files and the device here. So this is what the demo looks like. This is what the script for running the inference looks like. So what we did was we used this script, Python script, which has all the inference engine code in it. You can just add it according to your needs, this one. And then we gave the model file, XML file with M flag, and then gave the input images, and then device CPU. So this ran our inference. So we can see like we had the 6 images, and first, if you remember from IPEX inference, we had the first 3 images as classified as 0. So we can see like 0, the first image got classified as 0 since it has the highest probability. And then similarly for the second image, first 3 images was classified as 0. So we can see like probability of 0 is high. Similarly for fourth image and fifth and sixth image, we can see the results are consistent with OpenVINO inference also. So this is like a quick demo of inference on that data set which we used for IPEX also with the ResNet 50 model. So so yeah, like this we have more demos here. I can show you quickly with me.
So Aditya, I think in the interest of time, probably we are just 3 minutes away. So probably if you're okay, we can just kind of summarize and wrap it up. Is that okay with you?
Yeah, just 1 second.
Sure. Meantime, if there are any questions on OpenVINO, if you can just post it on Discord, we could just answer it. Thanks for.
So in this directory, if you see demos in Open Model Zoo demos, we have like so many demos for each use case. Like you can see classification and image segmentation, or so all the like use cases are there. You can use these demos first, but just you need to have the pre-trained model. You can download the pre-trained model using that downloader, and then convert it to IR using model optimizer, and then just use these demos to get the inference from that model. And all these steps required for this for running the demo is also available on OpenVINO documentation. So yes, Alex, sure. Now I have to.
Okay, thank you, Aditya. Jing, do you want to just show that the final foil, and then maybe you can just hold the foil if you can start sharing.
Yeah, you can start sharing the foil. I don't have specific foil to show.
Okay, all right. So let me just Aditya, if you okay, let me just all right. Can you all see my screen?
Not yet.
Not yet. Oh.
Yes. Now.
So Jing, did you want to cover this, or did you already cover?
I've already covered this.
Okay, awesome, awesome. So let's just have one final poll, and then I will just wrap it up. Can we have the Pradeep? Can we have the next poll, please? We have 45% of the votes. So which of the deep learning frameworks are not supported with OpenVINO? Okay, we have 57% votes so far, 65% of the thing, none of these, and okay, I think we can stop the poll. Yeah, Pradeep, I think we can stop the poll. Aditya, you want to clarify the response?
Yes. So all the models, like all the frameworks, TensorFlow, PyTorch, MX, and all are supported with OpenVINO. So answer should be like none of these. So I already showed with PyTorch, it needs conversion to OneNX, but with TensorFlow and MXNet, it's even like even direct. So like we don't need to convert it to OneNX or something like that. So they are even directly supported. And apart from these three, also like other frameworks are also supported, like Cafe and OneNX. So
okay, thank you.
Yeah,
thank you, Aditya. Okay, thank you all. I just want to kind of summarize. I think you saw, through this workshop, you probably saw how to use the Intel PyTorch extensions and extract the best juice out of your code. With with simple changes to your code, you can see how much performance you can actually extract, right? So this is the magic, that some of these extensions and the optimizations can really help you out. And you also saw, even if you don't want to change any code, you saw how we could get almost the same performance with OpenVINO, right? So essentially, what we want to leave you all with is these small changes can actually go a long way to basically get the best performance, out of Intel hardware and Intel architecture. So currently, what you saw is available on CPU under for the oneAPI framework. We eventually will expand these gradually into GPUs. We already have some internal versions that are supported on GPUs, etc. So by using these optimizations, you can actually minimize the amount of effort that you put to change the code to work on different hardware and extract the best use, right? So that's what I just want to leave you all with. Before I just conclude, please do participate in the contest. Make sure that you send the screenshots for all the exercises that we did today. And also, if you have any projects, interesting projects that you feel that you can that can benefit from either OpenVINO or the Intel PyTorch extensions, please do submit them on the Intel Devmesh, and also you can send it across to Kavita. You already have Kavita's email ID, so that would be great. And with that, maybe Kavita, if we have the final feedback survey, please do feel free to post it. We can get the feedback, and if there is any feedback, feel free to let us know. Any questions, we would still be hanging around on Discord for a few more minutes. Of course, even if you have, we will be watching Discord in case you have any questions at a later point as well. We will answer it. I know at least in the previous workshop, there were people who were actually doing the exercises until late in the evening. So we will support you with any issues that you may have executing these labs, etc. Right? So thank you so much. Really appreciate all your time. I hope it was good use of your time the last 3 hours. Thank you so much. And thank you all the presenters, Jain, Aditya, and Kavita, and Mandar, and Mary, for helping on the Discord and also the presentations and labs. Thank you so much. And thank you to all for attending.
Excellent presentation. Thanks, team. Over to you, Sujati, maybe for summarizing.
Yeah. Thank you, Kavita. Thank you, Lakshmi. It was a great session. Thank you, Zing and Aditya, for explaining the hands-on sessions. And it definitely gave us a lot of insights into using Intel extension for PyTorch. So, and I'm sure that attendees had a lot to learn from this session. So thank you so much for the workshop. Before we wrap up the session and the workshop for today, I would quickly like to shout out the names of the 10 lucky winners of the Intel DevCloud registration contest. Each one of them is going to receive Amazon vouchers worth 1,000 rupees. So the winners are Abhash Pandey, Naveen Krishnan, Keush Patel, Deepak Kumar Sharma, Remya Shivan, Kaushal Bora, Yash Sharma, Satyam Singh, Sureshta Paul, and Navneet Kumar. So these are the 10 names. So congratulations to all of you. All the winners will receive their prizes over email by Analytics India magazine. And I would also like to quickly remind you guys, like Lakshmi mentioned, please participate in the Devmesh project contest. Participants just needs to submit their projects using Intel DevCloud and oneAPI Toolkit. And you have time till 30th August. And please share the project link to kavita.arur@intel.com. And top 8 projects will stand a chance to win Amazon vouchers. So don't forget to participate in the contest. We would also like your feedback. The feedback link has been shared with you over the chat. So please share your feedback for the session. And that will be all for today. And thank you all for joining us at this workshop. Thank you, Kavita, once again for organizing this. Thank you so much.
Yeah, thanks to the AR team. This was a great collaboration, and we had some wonderful audience, participating and engaging. Like Lakshmi mentioned, we are still on Discord for next few minutes. So if you have any questions, please post in your Q&As on Discord, and we'll help address those. Thank you, and see you all soon.
Unanswered questions in Discord?
Yes, Lakshmi. Can we hang around there for a few more minutes?
Yeah.
If you have any questions.
Yeah, if there are any questions that need to be addressed, we can address it. Yeah, fine, no problem. Thank you.
Thank you, Lakshmi. Thank you, Kavita.
Thank you all.
Thanks, guys.